Welcome to Vision Plus and welcome back to Vision for Mathematics. We are looking at how we can find the equation of the tangent to a circle at a given point. Example 2, part A says that find the equation of the tangent to the circle. This is the circle at this point. Remember, this point here that we are given is a point on the circumference of the circle. And at that point, that is where the tangent is touching the circle. So this point is not where the tangent is drawn from to the circle, but it is the point on the circle where the tangent meets that circle. So for us to get the equation of the tangent, the first step that we do is to find, the key step is that we need to find the gradient function of the circle first. We need to analyze the circle first. Gradient function of the circle, and that is we are finding dy dx. We are differentiating the circle with respect to x. So what do we do here? We are going to differentiate both sides of the circle. That means we are differentiating with respect to x, and the function on this side I will be calling it a function at some point, and at some point I will call it a circle. They are the same, okay? We can treat it as a function. So it is given by x squared, our markers, plus y squared minus 30x plus 6y plus 109 equals to, I'm also going to differentiate the right hand side with respect to x, and there we have 0. So if we differentiate x squared, what do we get? We get 2x. What function are we differentiating? It is a function in x. So we put here dx, but it was with respect to also dx. So dx dx plus, if we differentiate y squared, we get 2y, and that is a function in y. So we put dy out of dx with respect to x. And then we come to, if we differentiate negative 30, we get, if we differentiate negative 30x, we get negative 30. And it is a function in x, so we shall say dx, and again with respect to x, dx. And then positive 6y, if we differentiate 6y, we get 6. It is a function in y, so we shall say dy dx. And then if we differentiate 90, no, if we differentiate 109, 109 is a constant. So if we differentiate a constant, we get 0 equals to, how about if we differentiate a constant 0, it still gives us 0. Now from here, we need to group the dy dx together, dy dx together. As you can see that this and this are cancelling, this and this are cancelling out. So here we shall have 2x plus 2y dy dx minus 30. This will cancel, plus 6 dy dx equals to 0. Now we need to group dy dx together because that is the gradient function of the circle. That is the derivative. So what are we getting here? We shall collect the like terms. That gives us here 2y dy dx plus 6 dy dx equals to, I'm carrying this 2 on the other side of the equation. So 30 becomes, negative 30 becomes positive 30. 2x here becomes negative 2x in that manner. Now let me factor out dy dx so that I will have 2y plus 6 dy dx. I factored out dy dx because it is common. So 2y plus 6 in that manner equals to 30 minus 2x. But we want to make dy dx the subject so that we get the gradient function. That means therefore our dy dx equals to 30 minus 2x over 2y plus 6. This is the gradient function that we are looking for. This is the gradient function of the circle. Okay, that is the gradient function of the circle. That gives us the gradient of the circle at any point on the circumference. What if we have this point now on the circumference? Always remember that this point is on the circumference. What if we have that point on the circumference? Therefore, at point 4 and -1, what is now the gradient? That means we shall say dy dx at which point 4 and -1 gives us, to substitute, this is x, this is y. That means we shall have 13 minus 2 times x, which is 4, out of 2 times y, which is -1 plus 6. Then you press your calculator. On the numerator, we are getting 30 minus 2 times 4, 22, yes, 22 over 2 times -1 plus 6, we are getting 4. Then we simplify. This is the same as 11 out of 2. So this is the gradient of the circle at point 4 and -1. But at this same point 4, -1, that is the same point where the tangent meets the circle. It implies that the gradient of the circle at this point is the same as the gradient of the tangent at that point. So what do we do there? We therefore conclude that this same gradient of the circle at this point will be that of the tangent at that point. So the gradient of tangent is 11 out of 2. Now let us find the equation of the tangent. Since we have, this is the gradient of the line because the tangent is a line, and this is one point on the line. So if you have the gradient of the line and one point on the line, then you can find the equation. And there are very many options. You can use y equals mx plus c. Okay, you can use y equals to mx plus c. Or you can use the other concept that I've been using, where I say now the gradient m is y2 minus y1 out of x2 minus x1. And you know your point as 4 and -1. So you can call this x1, y1. Then we substitute. What is the gradient? 11 out of 2 equals to this y2, now just write as y, minus y1 is -1 out of x2, write as x, minus y1, which is 4. Then you make y the subject. So we cross multiply. We shall have 11x minus 44 equals to 2y plus 2. That means if I make y the subject, I will have 2y equals to 11x minus 46. Therefore, y becomes 11x out of 2 minus 23. So this is the equation of the tangent when you use that method which I had. Or someone could use the equation of the line. So, and the point you have is 4 and -1. Call this x and y. Then you first find c. So you substitute it for y. -1 equals to, what is m? M is the 11 out of 2. What is x? X is 4 plus c. Then you find c. That is 11 times 4 divided by 2. And then you take it that side, it becomes negative. So -1 minus answer -23. So c equals to -23. After getting c, then you just come back and substitute for c and m, which is the gradient. Therefore, your y becomes, what is the gradient? 11 out of 2 x plus c, which is -23.